just a quick review of what we have done so far. So we introduced vectors in two-dimensional and three-dimensional space. So each vector is given by the three, so in three-dimensional space, each vector is given by three components, like the x, y, and z component, u1, u2, u3. And we have the addition of vectors and a scalar multiplication. So, and they are, so a scalar, both a scalar multiplication and addition are defined component-wise. So that means if you want to add two vectors, you add the components. If you want to multiply a vector by a number, which is also called scalar, you just multiply each component of the vector by that number. And then we define the dot product, sometimes also called the inner product of two vectors, is defined as following. So if u is u1, u2, u3, and v is v1, v2, v3, the dot product is a number which is given by this formula. U dot v is equal to u1 times v1 plus u2 times v2 plus u3 times v3. So for example, if you have u equal to 1, 0, 2, and v equal to 2, 2, 0, then u dot v, the dot product of u and v, is going to be u1 times v1, 1 times 2, plus u2 times v2, 0 times 2, plus u3 times v3, 2 times 0. So the last two terms are 0, so u dot v is just 2. So remember, the dot product, first of all, is the number. Second of all, is defined by this formula. And also remember that we have the standard unit vectors I, j, k, where I is equal to 1, 0, 0, j is equal to 0, 1, 0, and k is equal to 0, 0, 1. So sometimes instead of showing or representing a vector by its component, we can use the I, j, k symbols. So for example, you see the vector u here, which is 1, negative 2, and 2. We can represent u another way and say that this vector u is equal to I minus 2j plus 2k. That's basically the same, similar to saying that u is 1 minus 2, 2. Okay? So we defined the dot product and we saw that the angle between two vectors can be given using the dot product. So by this formula, the cosine of theta, theta is the angle between u and v, is given by u dot v divided by absolute value of u times absolute value of. Absolute value means magnitude. By absolute value of u and v here, I mean the magnitude of each of them. And also remember that the magnitude of each vector, so any vector you have, the magnitude is given by this formula. The magnitude of u is square root of u1 squared plus u2 squared plus u3 squared. Or basically, you can say that the magnitude of u is equal to square root of u dot u. Okay, so now I want to introduce another operations on vectors, which is called the cross product, or sometimes the exterior product. So if you have two vectors like u equal to u1, u2, u3, and v equal to v1, v2, v3, so the cross product u cross v is given by this formula. Is a vector. So the difference between the cross product and the dot product is that the dot product of two vectors is a number. It is not a vector. But the cross product of two vectors is again a vector, is another vector, which is given by this formula. So because it's a vector, it must have three components. So the first component is given by you multiply u2 with v3 and then subtract u3 v2. So the first component I'm writing by red is given by u2 times v3 minus u3 times v2. This is the first component. The second component, let me use another color, like green. The second component, what you do, you multiply u1 with v3 and u3 with v1. So I'm writing with green, but you have a minus sign. So it's minus u1 times v3 minus u3 times v1. And for the last component, the third component is given by basically the same pattern, but this time you multiply u1 with v2 and then multiply u2 with v1 and then subtract them. So the third component I'm writing with purple is u1 times v2 minus u2 times v1. Which you can write if you want to use ijk. It's going to be u cross v is going to be u2 v3 minus u3 v2 times I minus u1 v3 minus u3 v1 times j, and then plus u1 v2 minus u2 v1 times k. So this is the cross product of two vectors. And some interesting property of cross product is that the cross product of two vectors is perpendicular to both of them, to each of them. So for instance, if you have u and v, the cross product is perpendicular to both. So if this is u and this is v, then this guy is u cross v. So you see it's perpendicular to both u and v. So it has this unique property that the cross product of two vectors is perpendicular to both of them. And we are going to use this property when we are dealing with planes. We will see that. Okay. So let me just give you an example. So just as an example, compute the cross product. Imagine that as an example, if u equal to 1, 0, and 2, and v is 0, -1, and 3. So let's compute u cross v. So for the first component, it is u2 v3 minus u3 v2. So because u2 is 0, so it's 0 minus v u3, which is 2, times v2 is -1. So the first component of u cross v is 2. Because 2 minus 1 is -1, and there is a minus, it's 2. So the second component, 1 times 3 minus 2 times 0. So it's just 3. There is also a negative sign, -3. And the last component, I have to use this formula. The last component. So it's u1 times v2 minus u2 times v1. u2 and v1 are both 0. So it's u1 times v2. 1 times -1. So it's -1. This is just an example. Okay, is that clear? Any question? Okay, guys, so let's talk about the equation of a line. So to write the equation of a line, first of all, note that a line is determined by a point and a direction. So given a point and a direction, there is a unique line that passes through that point in that direction. So the equation of a line passing through let's say R0 equal to x0, y0, z0. With direction, or sometimes we can say parallel to. With direction means parallel to something. With direction, say v is equal to, for example, v1, v2, v3. Or you can say ABC is given by this. So this is the vector equation. Because we have vector equation and then we have also parametric equation. I write them separately. So the vector equation of a line is this, R. So R is a vector. Sometimes to emphasize that a quantity is a vector, the object is a vector, we put an arrow above it. But if I sometimes I don't, okay, so that's not a big deal. But this means I emphasize that these guys are vectors. So that means if I want to write this equation, the same equation in coordinates, means x, if r is x, y, z, this is equal to, and r0 is x0, y0, z0, plus t times v1, v2, v3. So this is called the vector equation of a line passing through R0 with direction V. So V is called the direction vector of the line. V is known as, this is the direction vector of a line. So this is the vector equation. We can also write the parametric equation, which is basically the same thing. So if you have a vector equation, so if two vectors are equal, it means that their component, each component of the two vectors must be equal. So in the vector equation, the two sides of the equation are equal. So that means each of their components must be equal. So if I just write down the component of the vector equation in details, I get x equal to x0 plus tv1, y equal to y0 plus t times v2, and z equal to z0 plus t times v3. So this is called the parametric equation of the same line. So we use both of them. Sometimes we use parametric equation, sometimes we use vector equation. Okay. So for example, write equation of a line passing through like R0 equal to 1, 2, 0 with direction V equal to 2, minus 1, minus 1. So the vector equation, as I just said, is x, y, z. This is the equation of this line. Is x, y, z equal to 1, 2, 0 plus t times 2, minus 1, minus 1. And t here is just a real number. I mean, in the previous equation also t is a real number. So this is the vector equation. The parametric equation is basically the same thing, except that you write this vector equation in details. So x is 1 plus 2t. Y is 2 minus t. Z is 0 minus t. Because you see, if you look at the right-hand side of the vector equation, so the x component of the right-hand side is 1 plus 2t. The y component of the right-hand side is 2 minus t. And the z component is 0 minus t. So now let me give you another example. If I say that write equation of a line passing through zero to 2 parallel to, so parallel to means in direction of, parallel to the y-axis. So now the question is, what is the direction of the y-axis? So we need the direction of the y-axis. What is the direction of the y-axis? The direction of the y-axis is just 0, 1, 0. So direction of x-axis is 1, 0, 0. Right? Direction of y-axis is 0, 1, 0. And direction of z-axis is just 0, 0, 1. So that means the equation of this line is xyz is equal to 0, 2, and 2 plus t times 0, 1, 0. Is that clear? Here, the point is, if you have x, y, z, so let's say that x, y. So this is x-axis, y-axis, z-axis. Then the direction of x-axis, the positive direction of x-axis is 1, 0, 0. So the positive direction of y-axis is 0, 1, 0, and the positive direction of the z-axis is 0, 0, 1. And these three vectors are orthogonal to each other. They're perpendicular. Okay. By the way, so here I wrote the equation of a line in 3 dimensions. We can also have, we can also formulate the line, equation of a line in 2 dimensions. But in 2 dimensions, it's everything the same, except that you have only 2 components, like x and y. We don't have z. So in 2 dimensions, the equation of a line is xy is equal to x0, y0 plus t times the direction vector. So that means x is equal to x0 plus tv1 and y is equal to y0 plus tv2. This is the equation of a line in 2 dimensions. So let me just explain to you how it relates to lines, the equation of a line that you learn in elementary school. Because you learn equation of a line in elementary school, right? How this relates to equation that you learned in the past? Because so the equation that you learned, if you look at the parametric equation, so from the first equation, you can say that x minus x0 divided by v1 is equal to t. From the second equation, you can say that y minus y0 divided by v2 is also equal to t. Because both of them are equal to t, so you can equate them. So x minus x0 over v1 is equal to y minus y0 divided by v2. So that means y minus y0 is equal to v2 over v1 times x minus x0. Okay. And that's it. So in elementary school, you see this equation. I mean, you don't have v2 and v1, but you have basically a slope of a line. So we usually have y minus y0 equal to m times x minus x0, in which m is the slope. But we know that if you have a direction vector v1 and v2, the slope is v2 over v1, right? It is the same thing. So the last equation is called the scalar equation of a line in 2D. So the first equation, the equation on the top are the vector equations and parametric equations. And the last equation that you learn in elementary school is basically the scalar equation of a line. Okay. Okay. Now, another topic, or maybe a problem that one might ask, is that if you have two lines in the space, if you have two lines in three-dimensional space, so we have three-dimensional space, and you have two lines. So now the question is, how we can tell whether the two lines intersect each other, parallel to each other, or identical, that means are the same, equal, or maybe they are just skew lines. So skew lines means they are not intersecting and they are not parallel. So for example, look at this, look at me here. So these two lines are skew because they don't intersect and they are not parallel. But if you have these two lines, so in anything like this, these two lines are parallel. These two lines are parallel. But these two lines are not parallel, they're skew. Okay. So two lines can have 4 cases in terms of whether they intersect or not. So one, so in general, there are 4 possibilities. So one is the two lines are intersecting. means they cross each other. Second possibility is that they are parallel but not equal. Third possibility is that they're equal, so they're the same line. Or identical. And the fourth and last possibility is that they are skew. So for instance, the line, so let me give you one example of each of these possibilities. So for example, the line x-axis and y-axis. Imagine x-axis and y-axis. They intersect at one point. What is the point of intersection? So this is for the first case. So for first case, you have x-axis. So if you want to write the equation of the x-axis, so the direction is 1, 1, 0, and it passes through the origin. So the equation of x-axis is basically x, y, z equal to t 0. I mean, let me just, because it passes through the origin, so it's 0, 0, 0 plus t times 1, 0, 0. This is the equation of the x-axis, which is basically equal to t 0, 0. And the y-axis, x, y, z equal to 0, 0, 0 plus s times. Whenever you want to write equation of two lines together, it's better to use two different parameters in order not to mistaken them. So we use two different parameters, one t for one line, one s for another line. So the direction of y-axis is 0, 1, 0. So this is equal to 0 s. Of course, x-axis and y-axis meet each other at the origin. And there is only one point of intersection, and that is origin. So intersection is 0, 0, 0. So now let me give you another example of two lines that are parallel, not equal. Can anyone tell me two lines that are parallel but not equal? So one can be like the x-axis, for example. So one of them x-axis, like x, y, z equal to t 0, 0. This is one of them, which is x-axis. Another one, the line which is parallel to this, but passing through like 1, 0, 0. Not 1, 0, 0, sorry. 0, 1, 0. So the other line is parallel to x-axis, but passing through 0, 1, 0. Can you turn off your speaker? Kenny? Do you hear me?
Hear you.
Okay, can you mute yourself? Because
Oh,
I hear
sure.
something. Okay, thank you. So this line is a line that is parallel to x-axis, but passing through the point 0, 1, 0. So it's xyz equal to t1 and 0. So these two lines, they are parallel, but not equal, because they don't intersect. But they're parallel, because they both have the same direction. So let me tell you an equation, an example of two lines that are equal. For example, the first line is xyz is equal to 1, 2, 0 plus t times 1, negative 1, 0. And the second line is given xyz equal to so, and the second line is xyz is equal to minus 1, 4, 0 plus s times 2, minus 2, and 0. So first of all, note something, that the direction vectors of the two lines are parallel. So because one direction vector is 1, negative 1, 0, the other direction vector is 2, negative 2, 0. So one of them is 2 times the other one. So the direction vectors are parallel. They're the same direction, right? If you have two vectors, one of them is a scalar multiple of the other one, they're parallel. And you can see that they're identical because basically one of them is 2 times, the equation of the one of them is 2 times the other one. So another way to see that these two lines are identical is you can solve the equation. Let me tell you. So the first so another way to see that these two lines are identical, I mean, in general, if you want to see whether two lines meet each other, they intersect or not, you just write the XYZ equation of each of them. So for example, the first one, the parametric equation is x equal to 1 plus t, y is equal to 2 minus t, and z equal to just 0. This is the first equation. The second equation, the second line is given by x equal to minus 1 plus 2s y is equal to Oh, sorry, here I made a mistake. X must be -2. Just give me a second, sorry. So the parametric equation of the second line is x equal to -1 plus 2s, y equal to 4 minus 2s, and z equal to 0. So first of all, z is 0 for both of them. So that is good. Now, if the two lines are identical, so if you equate x, so just look at the x component of each line. So here is 1 plus t minus 1 plus 2s. So 1 plus t must be equal to -1 plus 2s. And then you have 2 minus t, the y equation, equal to 4 minus 2s. Okay, now what is the solution to the first equation? So for the first equation, you can write t in terms of s. For example, from the first equation, it follows that t equal to -2 plus 2s. Let's plug this into the second equation. If you plug this into the second equation, you get 2 minus -2 plus 2s. So is equal to 4 minus. What you get is 4 minus 2s equal to 4 minus 2s. So, and you see from here, there are infinitely many. So for any s, so any s satisfy this equation. So there are infinitely many solutions to this equation, because if Sn is any real number, it satisfies this equation. So that means there are infinitely many solutions to the intersection of the two lines. That means the two lines must be identical. So identical lines. So in general, if you want to see if the two lines, they have intersection or they are parallel or so, so you have to write the parametric equation of each of them, like what I did, and you equate x, y, z component. So you have basically, in general, you have 3 equations with 2 variables, because s and t are the 2 variables. If there is only one solution, that means they intersect each other. There is only one point of intersection. If there are infinitely many solutions, means they are identical. And if there are no solutions, there are 2 possibilities. Either they are parallel or they are skew. And you can say, when you can tell whether they're skew or parallel based on their direction vectors. So if the direction vectors are parallel, then they are parallel. Otherwise, they're skew. Okay. I will give you more examples. I will solve more problems later about this topic. Okay. So next, so we have done equation of lines. Now let's do, maybe we can have a like a 10 minutes break, and then I will go over equation of planes. So that is the last topic, equation of planes. So these are the questions, your assignment basically, okay? So for example, let me tell you some remark. If you look at question 11, so you want, for this question, you want to write equation of a line that passes through 2 points, A and B. So you have 2 points, A and B. You have 2 points. And you want to write the equation of a line that passes through these 2 points. So now the question is, in order to write the equation, we need a point and the direction vector. So the question is, we have 2 points, so of course we have 1 point. But what is the direction vector? So the direction vector, because it passes through A and B, so the direction vector is simply AB. So direction of this line is V equal to AB. So what is AB? AB is B minus A, as you know. So the direction vector V is equal to B minus A, so it's 1 minus, so 2 minus 1 is 1. Minus 9 minus 5 is minus 14, and 0 minus minus 4 is 4. So the direction vector of that line is given by AB, which is 1 minus 14 minus 1. So you have the direction vector, and you can use either of these 2 points as a point, and then you can write the equation. So you remember the equation of the line is just like x, y, z equal to like a, for example, plus t times v. So you just plug a and v, you find the vector equation. And then you can also write the parametric equation. Parametric means, so you write this equation, you look at this equation. So what is x? What is y? And then write z. Okay? Now, another remark. So question 13, it says find the parametric equation, question 13. Find the parametric equations of the line through the point P that is perpendicular to both of these lines. Because it says it's perpendicular to both of these lines, that means the direction vector of the line that we are looking for is perpendicular to the direction vector of these 2 lines. So what is the direction vector of these 2 lines? So one direction vector is, so for one of them, the direction vector is this. Another one, the direction vector is this, right? So let's say that this one is U, and the second one is V. So the direction vector of the line we are looking for is perpendicular to U and V. So you remember I told you at the beginning of today's session that u cross v is perpendicular to both u and v. And that is the unique vector perpendicular to u and v. So that means the direction vector of this line is basically u cross v. So the direction vector of the line we are looking for. So for question 13, the direction is given by u cross v. So you have to compute u cross v. That is the direction vector. And then you have a point. And then you can write the equation of the line. Okay? Okay. Next, we have equation of planes. So there are two ways, or say three ways, to write equation of a plane. One is the vector equation and parametric equation. Another way is the scalar equation. So first I describe the vector equation. So first of all, each plane is given or is determined by two vectors. So for each plane, we need two vectors like u and v. These are called the direction of the plane P. So this is a plane P. So we need two vectors that are the directions of basically this plane. So if you have only one vector, then one vector can give you direction of a line. But for a plane, we need at least two vectors. So these are u and v are direction vectors. And assume that R0 is just a point on the plane P. So we want to find equation of a plane with uv direction vector passing through R0. So the vector equation of such plane is given by R equal to R0. So these are for emphasizing our vectors plus S times U plus T times V. In other words, this is just the vector equation. X, Y, Z is equal to X0, Y0, Z0 plus S times, and imagine that U is just U1, U2, U3, and V is just V1, V2, V3. So the equation, the vector equation is just X0, Y0, Z0 plus S times U1, U2, U3 plus T times V1, V2, V3. So this is the vector equation. The parametric equation, exactly the same equation, except that you just write the component of this equation in details. So that means the parametric equation is basically x equal to x0 plus SU1 plus TV1, y equal to y0 plus SU2 plus TV2, and z equal to z0 plus s u3 plus v, sorry, plus t times v3. So the first equation is called the vector equation. The second equation is called parametric. And here, S and T are real numbers. They are basically parameters, two parameters. So in order to write equation of a plane, you need two direction vectors and 1 point. And here are the equation, vector equation and the parametric equation. Okay, so there is another way to describe a plane. So it is just a scalar equation of a plane, and that is the following. See, if you have a plane with two direction vector, then that means this two direction vector, if you compute the cross product of the two direction vector, let me just draw another picture. Imagine you have a plane. And on the plane, you just take 3 points. Let's say this is A, B, and C. You have 3 points on the plane. By the way, if someone gives you 3 points, you can basically write a plane. If the 3 points are not in just one line, you can write a plane, equation of a plane. You can find a plane that passes through these 3 points. So the two directions of this plane are just AB and AC. Right? So given any 3 points that are not in the same line, you can find a plane that contains these 3 points by just, if you have A, B, C, then the two direction vectors of the plane are AB and AC. So AB, so U equal to AB, and V equal to AC are two direction vectors. And you can write the equation of the plane with 3 points. So another thing is that if you find the cross product of the two direction vectors, so you get another vector that is perpendicular to the plane. So imagine that this is the cross product. I call it N. So N is a vector that is perpendicular to the whole plane. So what does that mean? That means that if you take any 2 points, say, so imagine that B equal to X, Y, Z, and A equal to X0, Y0, Z0, then N is perpendicular to AB. N is perpendicular to AB, to the vector AB. But AB is just X minus X0, Y minus Y0, and Z minus Z0. And if N is like A, B, C, so the three components of N is A, B, C, that means A, B, C dot product with AB, which is X minus X0, Y minus Y0, Z minus Z0 equal to 0. Because if two vectors are perpendicular, that means the dot product of them is 0. So that means A times X minus X0 plus B times Y minus Y0 plus C times Z minus Z0 equal to 0. And this is called the scalar equation of a plane. So the scalar equation of a plane, you need the normal. So N, the vector N is called the normal of the plane. So here, let me just write this in detail. So a scalar equation of a plane with the normal vector N equal to A, B, C, passing through say this point X0, Y0, Z0 is given by this equation. A times X minus X0 plus B times Y minus Y0 plus C times Z minus Z0 equal to 0. This is the scalar equation of a plane with normal vector N, which is ABC, and which passes through just one point that you know, like X0, Y0. So here we know this point, X0, Y0, Z0, and we know the normal, which is ABC. So this is the equation of the plane. For example, let me give you one example. So find a plane that passes through these points. A equal to 1, 0, 2. B equal to 2, 1, 4. and C equal to 3, 2, minus 1. So we have 3 points. So basically you have 3 points, A, B, C. You want to find a plane that passes through these 3 points. So imagine that this is like A, this is B, and this is C. So there are, as I said, there are 2 ways to do this. In order, if you want to write the vector equation, so first write solution 1 vector or parametric equation. If you want to write the vector equation, then you can just, the direction vectors are AB and are AC. So the direction vectors I just say directions are U equal to AB, which is equal to, what is AB? AB is AB minus A, which is 1, 1, 2, and V is AC, which is C minus A. C minus A is 3 minus 1 is 2, 2 minus 0 is 2, and then minus 1 minus 2 is minus 3. So you have the directions. So that means the vector equation is the following. So the vector equation is x, y, z is equal to, you can write, so as a point, you can take either A, B, or C. I just take A. So A plus TU plus SV. So that means x, y, z is equal to 1, 0, 2 plus t times 1, 1, 2 plus s times 2, 2, minus 3. So this is the vector equation. The scale, the parametric equation, the same thing, but just you write x, y, z separately. So x is the first component. So you can look at the right-hand side. So you have 1 plus t plus 2s. And then y is equal to 0 plus t plus 2s. And then z is equal to 2 plus 2t minus 3s. This is the parametric equation. Clear? Is that clear? Any question? Yeah. I will do it for this example. So if I want to write then a scalar equation, I need the normal. But what is the normal? Normal is the cross product of AB and AC. See, if I have the cross product, let's say that this guy is the cross product. So the cross product, the normal of the plane is the cross product of the two directions. So I need to find the cross product. So we have AB and AC. So I need the cross product. N is equal to AB cross product with AC. So what is the cross product? So you remember the cross product is a vector whose first component is given by 1 times -3 minus 2 times 2. So the first component is -3 minus 4 is -7. How about the second component? The second component is given by 1 times -3 minus, again, 2 times 2. One minus 3, 2 times 2. It's the same thing. It's -7, but for the second component, we also have a minus at the end, so it's 7. And the first component is given by, so you multiply, let me use another color. You multiply 1 with -3 and 2 with 2, yeah. No, yeah, that's right. For the first component, this time is minus. Second component, y minus. The first component, the third component, oh, sorry, the third component is given by 1 times 2 minus 1 times 2. So the third component is just 0. So if you want the formula, the original formula for the cross product, I can show you. So here is the formula for the cross product. So if you have U1, U2, U3, V1, V2, V3, the cross product of UV is a vector whose first component is U2, V3 minus U3, V2. So this is the first component. The second component is negative U1, V3 minus U3, V1. And the third component is U1, V2 minus U2, V1. So if you apply this formula to these two vectors here, so the first component, let me do it again, is -3 minus 2 is -7. The second component is minus, again, -3 minus 4, which is -7 is 7. And the third component is 2 minus 2 is 0. So that is the normal. And remember that equation of a plane with normal n passing through, so we have 3 points. I just can take any of them. So this is the normal. And I know that it passing through A equal to 1, 0, 2. So the equation of a plane passing through x0, y0, z0 with normal n equal to ABC. Let me just write the equation. The formal equation is, so if this is A, this is B, this is C, and this guy is x0. The equation of a plane is basically A times x minus x0 plus B times y minus y0 plus C times z minus z0 equal to 0. So is minus 7 times x minus 1 plus 7 times y minus y0, y0 is 0, plus C, which is 0, that's it. Because it's 0, actually you don't need, but I just write it. So the equation of the plane is given by 7x minus 7 plus 7y. So I can say that 7x plus 7y is equal to 7, or I can simply say that x plus y equal to 1. Okay, so I made a mistake. So A is minus 7. I just put 7. Sorry, guys. So A is minus 7. I correct it here. A is minus 7, B is 7, C is 0. So what you have is basically minus 7 times x minus 1, so which is minus 7x minus 7x plus 7 plus 7y is equal to 0. So you have minus 7x plus 7y is equal to minus 7. So basically you have x minus y equal to 1. If you divide this by minus 7, you get x minus y is equal to 1. Okay? So this is the scalar equation of the plane. This is the scalar equation of the plane. Now, so let me tell you one more thing, and that is, if you have two planes, for example, here, you see three planes in this picture. In this picture here, you see three planes. So if you have two planes, then you want to see whether they intersect each other or they are parallel to each other, okay? So how you can do that? So if they are parallel to each other means, so if you have the scalar equation of the planes, means their normal vector are in the same direction. So if the normal vectors are of two planes are in the same direction, That means one of them is a scalar multiple of the other one. That means the two planes are parallel. So if two planes are parallel but not equal, means not identical, then they don't intersect. They have no intersection. So there are three basically possibilities for two planes. Either they intersect each other, and when they intersect each other, they intersect each other in a line. Or they are parallel but not identical. That means they don't have any common point. Or the last possibility, third possibility, is that they are identical. That means basically they have the same, they're the same, they're equal. Okay. So and if you have two planes and you want to see, for example, let me look at this question 18a. Question 18a. It says that determine if the planes in each set intersect. If so, describe how they intersect. So one is 2x. Let me write it down. Question 18a. Equation of one of them is 2x plus 5y minus 7z equal to 31. The other one is x minus 2y minus 5z is equal to minus 9. So first note that the normal of the first plane, say n1, is equal to 2, 5, minus 7. So the normal are the coefficient of x, y, z whenever you have the scalar equation. So, and the normal vector for the second plane is 1, -2, and -5. Since these two vectors are not parallel, they're not in the same direction, so that means these two planes must intersect. They must intersect, so they intersect. Now the question is, can we find the line of intersection? So you have to solve these two equations, basically. 2x plus 5y minus 7z is 31, and x minus 2y minus 5z is minus 9. So one way to do this is, so there are different ways. So for example, you can eliminate one of the variables, either x, y, or z. So here I try to eliminate x, for example. If I multiply the second equation by -2, so I multiply this by -2, so I get minus 2x plus 4y plus 10z equal to 18. I just multiply the second equation by -2. And I just write the first equation. I just copy the first equation. You have 2x plus 5y minus 7z equal to 31. So these are the new equations. Now, if you add these two equations, if you add them, so you can eliminate x, because 2x minus 2x is just 0. So if you add these two equations, you have 2x minus 2x is 0, plus 9y plus 3z equal to 31 plus 18 is 49. So the new equation is 9y plus 3z is 49. And remember, I have also another equation. I just also copied the first equation. So I have two equations, 2x plus 5y minus 7z is 31. And the second equation, where I eliminated x, is 9y plus 3z equal to 4. So as I said, these two planes intersect in a line. So I want to find the equation of the line. Because I have two equations and three variables, I can let one of the variables be a free variable. For example, I let z be a free variable equal to t. If z is equal to t, then from the second equation, I get 9y equal to 4 minus 3z equal to 4 minus 3t. So that means y equal to 4 over 9 minus 3 over 9 times t. So this is y, and I have z equal to t, y equal to this. I plug these two into the first equation now to find x. So I get 2x. I plug these two, y and z, to the first equation. So I get 2x is equal to 31 minus 5y. Oh, sorry, that is 7z, not y. So 2x is 31 minus 5y plus 7z. So that means an x, z equal to t, y equal to 4 over 9 minus 3 over 9 t. So x equal to 31 minus 5 times 4 over 9 minus 3 over 9 t plus 7 times t. So x equal to, so you have 31 minus 20 over 9. So what is 31 minus 20? So it's a constant number. No, it doesn't matter. So 31 minus 20 over 9. And then you have minus 15 plus 15t over 9 plus 7t. So you have x, y, z, all of them in terms of t. And this gives you basically a line. So the intersection of these two planes is a line with equation z equal to t, y equal to 4 over 9 minus 3 over 9t, and x equal to, of course, you have to simplify x, but x equal to 31 minus 20 over 9. You can simplify this expression, and then 15 over 9 plus 7 times t. Okay, so I don't have enough space, but you can simplify x. So x, you can say, for example, x equal to a constant number plus something times t. and that is x. Okay, guys? Do you have any